The foundation level up to grade C. This is chapter 2, sequences, starting at page 32, question 2, F grade only. It says write down the next two terms in the following sequences. Well, here's a sequence. It goes 3, 7, 11, 15. Well, as you can see, it goes up by 4 each time. So the next two terms will be, just change to blue, add on 4. 15 plus 4 makes 19, add on another 4, we have 19 plus 4 is 23, and that's about the level of it really. Sometimes you may be required to add, sometimes you may be required to take away, other times you may be required to divide, and other times you may be required to multiply. So you need to study the sequence carefully, apply one of these 4 rules, for the basic ones anyway. Alright, that's that one. I think I'll do the next one. Look at this, it goes 1, in fact this is 2e, 1, 2, 4, 8, 16. Look at this one here. How do you get from 1 to 2? The same rule must apply to go from 2 to 4. The same rule must apply to go from 4 to 8. And the same rule must apply to go from 8 to 16. Look at that. Multiply by 2, 1 times 2 is 2. Multiply by 2, 2 times 2 is 4. Multiply by 2, 2 times 4 is 8. And multiply by 2, 8 times 2 is 16. So the rule for the sequence is just multiply by 2 or times by 2. Question 4. It's exactly the same thing but using different wording. Write down the term to term rule for the sequence. Well, if I look at B, for example, for B, it goes 0, 5, 10, 15, and off it goes. Term to term, I'm going from the first term to the second term, I'm adding 5. I'm going from the second term to the third term, or the third member in that family, I'm adding 5. I'm going from 10 to 15, the third to the fourth member, I'm adding 5. Therefore, the term to term rule is, here's your answer, add 5. Right, that's all there is to it really. We actually did do term to term there, but that's the first time this this language has been used in the book so far, and that's located on page 33. Alright, let's move on. I don't think I'll do any more of those actually. I've got to investigate these sequences. Here's a nice one. These are the dodgy ones, the scary ones, probably grade D. Question 10. I've got to investigate these ones. 1, 4, 9, 16. Well, this doesn't quite work out in the same way. Look, got a gap of 3, gap of 5, a gap of 7. 3, 5, 7. I suppose that's something of a sequence. But look at that. 1 squared is 1. 2 squared is 4. 3 squared equals 9. 4 squared equals, and this is meant to be an equals, but never mind, I wrote it around the wrong way. And these are just, it's a sequence of square numbers. It's a sequence of square numbers. Alright? And you just need to spot them really. If you know your square numbers, then you won't get caught out by an odd looking sequence like that. Here's a nice one, write it down here. 1, 8, 27, 64. If your eye isn't trained into recognizing these numbers, you won't recognize that they're in fact cube numbers. Look at this. 1 cubed is 1. 2 cubed is 8. 2 times 2 times 2 is 8. 3 cubed is 27. 3 3s are 9. Times 3 again, we get 27. And 4 cubed is 64. So these are called cube numbers. I don't want to do any more of those. I think you got the idea. I've got time to go into section 2.2. It's just a very short section there, and it's going to get a little bit more serious. Let's just turn the page over and let's hit that red, shall we? Right, it says, question 1, write down the first 5 terms of the sequence whose nth term is, in other words, here is a rule. So here I go. Here's a rule. The rule is n plus 5. So the first term, where n equals 1, the answer is going to be 1 plus 5 to make 6, and that's the first member of the term. The second member of the sequence, n is worth 2, so I'm going to have 2 plus 5, because look, it's the number plus 5, will make 7. Next one. The third term will be where n equals 3, so substitute n equals 3. I've got 3 plus 5, and that will give us 7. Let's work down here. The fourth member of the team, the fourth term, where n equals 4, I'm just going to say 4 plus 5 is oh, I should say 8. Oh dear. 4 plus 5 is 9. And the fifth member of the family, where n equals 5, the fifth term, you can calculate it by saying 5 plus the 5 makes 9. Alright, let's just do one more. Let's just do D. I've got here 2n minus 7. So if I take n equals 1 first, I'm saying 2 multiplied by 1, take away 7. Well, 2 ones are 2, take away 7 is minus 5. That's the first member of the sequence. Next member, 2 times 2, take away 7. Or 2 2s are 4, take away 7. That puts me on minus 3. 2 times 3, that's the third member, is 6. 6 take away 7 is minus 1. Let's work down here. 2 multiplied by 4 is 8. 8 take away 7 is 1. And finally, 2 lots of 5. Take away the 7 is 10 take away 7, which is 3. Look at the sequence. We're going minus 5, add on 2, takes us to minus 3, add on another 2, takes us to minus 1, add on another 2, minus 1 plus 2 gives us 1, and of course 1 plus 2 gives us 3. Right, very, very easy. So all we have to do in finding the sequence, you just you generate the sequence by placing the first, second, third, fourth, fifth, whatever number you're told to go up to, then working out the answer. Let's do one down here in blue, or maybe green, nice and bright. Don't be worried about things like this. N squared plus 2, that just means you take the first one, square it and add 2. 1 times 1 is 1, plus 2 is 3. Next one, take the second term, n squared plus 2 makes, well, 2 2s are 4, plus 2 is 6. Next one, take your 3, square it, that's 9, add the 2 because it says so, comes to 11. 4 squared is 16, plus the 2 is 18, and squeeze this one down here, I think. 5 squared plus 2, well, 5 5s are 25, add the 2 is 27. Here's a lovely sequence going from 2 to 27, it just sort of keeps going down that way. Alright, that's it. Then it asks you something quite rude in question 2. It says write down the 100th and the 101st terms of these sequences. Now, it doesn't matter, you don't have to start from 1 and go all the way up to 100. If I've got, for example, this one here, which says 3n minus 10, and I want to know the 100th term, I'll just put 100 in there where the n is. So what have I got? 3 multiplied by 100, take away 10. Well, 3 multiplied by 100 is 300. 300 take away 10, 290. That's all there is to it, okay? No fear there, is there? Let's turn over a page. Right, now, this is my favourite bit, question 5. I've got to write down the nth term of the following linear sequences. In other words, there's no squares in them. There's no n squared or x squared or anything like that. Take a good look at this. If I write the sequence in black, this time we're going to find the rule by studying the numbers 3, 7, 11 and 15. Just to remind you, that's the first member of the family, term number 1. That's the second member of the family, term number 2. Third member of the family, and the fourth number along. And eventually just keep going forever and ever, amen, and you'll find the nth term, so you can work out any member of the family, provided you know what the number is you've been given. Now check this. This is what I do. I say to myself, let's just change it to red, it's a bit brighter. I say to myself, how do you get from 3 to 4? 3 to 7, you add on 4. How do you get from 7 to 11? You add on 4. How do you get from 11 to 15? You add on 4. Guess what? It's a 4n rule straight away. So working backwards then, to find the 0 term, this will be term 0, the 0 member of the family. What number, when you add on 4, becomes 3? Answer, minus 1. Minus 1 plus 4 makes 3, and minus 1 is a 0 term. So the final rule is 4n minus 1. But is it correct? Let's test it out right now. So I've got here 4n minus 1. Remember, I was given, if I was given this sequence as a question and I'm told to work out the 5th member of the family, or the 4th member of the family, or the 3rd term, let's just do the 3rd term anyway. If I shove a 3 in there, I've got 4, lots of 3 is 12, take away 1 comes to 11. Is the 3rd term 11? Yes it is, I've got it right. There's the 11 and there's the 3rd term. Let's just prove that it works again for the 4th one. 4n minus 1. Substitute a 4 in there for the 4th member of the family. 4 times 4, 16, take away 1 is 15. Is my 4th term 15? Yes it is. There's my 4th term and there's a 15. Let's do one more linear sequence. This one looked frightening, it's so not. Minus 5, minus 1, 3, 7. Really easy. How do you get from minus 5 to minus 1? You add 4. How do you get from minus 1 to 3? You add 4. And what about from 3 to 7? Well, you add 4. We know we've got it right because the sequence goes up plus 4 each time, term to term. So I know it's a 4 times n rule. Again, 1st, 2nd, 3rd, 4th, nth member. Keeps going that way. In fact, sequences go backwards as well. Let's find the 0 member. What number, when you add on 4, gives you minus 5? Think about it. I believe it's minus 9. Minus 9, climb up 4 degrees, is still 5 degrees below 0. Think about it. Minus 9, go up 4, takes you to minus 5. Therefore, the rule is 4n minus 9. Let's just test it out. Put a nice box around that, and we'll study it. Pick any one you like. Let's do the 3. Let's try it out there. 4 multiplied by 3 is 12. 12 take away the 9, because that's what it says, comes to 3. Yes, 12 take away 9 is 3. And look, the 3rd member is a 3. Do it one more just to be absolutely sure. Work down here. I'm testing 4n minus 9. Let's take the 4th one. So 4 times 4 is 16. 16 take away 9 is 7. And look, the 4th member of the family is in fact 7. So I know that's right, and I know the sequence is correct. That's essentially how you do a term-to-term method, by using little loops, I call them, and you can generate the rule for the sequence. If you look at question 8 yourselves, you can see you can generate a sequence just from a pretty pattern given to you in a picture. Some of these are quite tricky, and so I'm going to pause now. I might do a couple from the assess and just join the videos. I do them separately. See how we feel about that. Okay.